Hello guys, welcome back to the next lecture of Advanced DSA. We have learned our pattern based programs. We have started with the searching algorithm and we have already seen linear search. So in this class, we'll see binary search, one of the very important searching algorithm from the interview point of view and also on the basis of other concepts which have been covered in this. Right, so let me just explain you binary search, but before that, this is my website. www.bigdatayatra.com. In this website you can find my latest courses related to data engineering and Python DSA. This includes all the basically skills which you need to become a data engineer in 2026. You can acquire, if say suppose if you enroll in this big data and Apache Spark Mastery, you can acquire big data, Hadoop, Spark, Python, DSA, SQL, resume building, project, everything at just 3,999, and then this is a separate course for Python and DSA. If you enroll in this big data and Apache Spark Mastery, Python and DSA, it is included in this as well. So, and this is our Instagram. We have been posting daily reels since last 55 days, and you can see we are teaching you through reels as well. So do follow us on Insta. Now, we all know what is search, right? We have already seen what is search, that if element is present in an array, return the index at which it is present, and if the element is not present, return -1 or none. This is our search, we all know, right? And what is linear search? Say suppose I have this array having 4 elements, 10, 20, 30, 40 for example, right? And 10 is present at 0th index, 20 is present at first, 30 is present at second, 40 is present at third. So I will start a loop and I will traverse the whole array. I will compare the item I need to search. Say suppose it is 30. I will compare each element with 30, whether this is 30, whether this is 30, whether this is 30. Yes, it is 30, so I will return the second index because it is present at second index, and I will break the loop. And if it is not present in the entire array, say suppose I am searching 60, it is not present in this array, so I will return -1 or none, right? So this is our linear search, right? And what is the time complexity of linear search? Big O of n. This we have already seen. If you have not watched my linear search video, do watch it before you watch binary search, correct? Then let's just proceed with binary search. Right? What does binary mean here, right? And we have already seen about searching. So what is binary? Binary means to divide array. Divide. What does binary mean here, right? Divide array and work on half of the array. Half of the array. That is, say suppose this is my array. This is my array. What binary search says is, don't work on this entire array. Instead, find the middle. Find the middle. So suppose middle is this. We'll see the formula how to find the middle. And then work either on the left part of the array, or on the right part of the array. This is my left side, right? This is my left side. This is my middle. This is my right side. So what binary search says is, find the middle and decide whether the element you are searching is present on the left side or the right side. If it is present on the right side, search only on the right side of the array. That is this. Right? And if it is present on the left side, then only search on the left side of the array. That is this. Do not work or do not search the entire array. This is binary. This is the significance of binary here, right? And I hope it is clear. So at any point of time, you will see we will be working on either half of the array, and we will keep on finding middle index, and then depending upon the middle, we will decide whether to work on left part, whether to work on right part. Okay. Yes. So this is binary. This is binary in binary search, but a very important prerequisite, very important prerequisite, or a necessary thing about binary search is array has to be sorted. if the array is not sorted, you cannot apply binary search on it. Very, very important. Very, very important. Now you only tell me, can I apply binary search on this array 8, 10, 6, 14, 20? Is it sorted array? Is it sorted array? No. So I cannot apply binary search. I can apply binary search if it is sorted like 6, 8, 10, 14, 20. Now it is sorted. Now I can apply binary search on it. So binary search can only be applied on a sorted array. And what does binary means? We have already seen, find the middle index, work on either half of the array, and what is searching we already know. So these are the some important things which you need to know before applying or before learning about binary search. Now if you know this, I know you know this now. So let's jump to binary search. Let's jump to binary search. Right. So what are the steps involved in the binary search? For that, let me take one example of an array, sorted array rather. The array is 10, 20, 30, 40, 50, 60. These 6 elements, okay, I have in my array. These 6 elements I have in my array, they are present at this index 0, 1, 2, 3, 4, 5. 6 elements indexed from 0 to 5. Okay. Now what binary search says is, I have to find middle, right? I have to find middle of the array, middle. But before that, middle index, I need to find middle index. How to find middle index? I need to find middle index. So can I say, to find middle index, I will take the last and the very first index, that is 0th index and 5th index. I will sum and divide so that I can find the middle, right? How do you find middle? Say suppose I have this 8 elements, 7 elements, right? So the middle is this. How did we find it? Take this, divide by 2, sum and divide by 2. Then you will be able to find the middle. So can I say, this is my lower index, this is my lower index, this is my upper index or the last index here. I need to find middle. I need to find middle. So can I say, to find the middle index, can I write lower plus upper, sum these two and then divide by 2? Can I write like this? Yes, of course. This is how we find the middle or average, you can say, right? The middle index we need to find. So what is the lower index? Lower index in this case is 0. Upper index in this case is 5. Divide by 2. I will get 2.5. Is 2.5 a possible value for index? No. Why? Because I have my indexing on integer based. This is integer based indexing. Indexing is always in integer based. It is not float based or decimal based, right? So what I need to do, instead of directly dividing it by 2, I will do the floor division here. I will do floor division. What is floor division? It is lower plus upper and then double slash 2. Double slash 2. What is the difference here? Now, when I divide 5 by 2, I get 2.5. But when I will 5, floor division will 2, I will get the lower precision value. What is the lower precision value of 2.5? It is 2. So I will get this. Let me just go to PyCharm. Let me just show you how it is working. So when I will do 5 by 2, I will get 2.5. But when I will do floor division, I will get the lower value, that is 2. Okay. So now, if floor division is clear, so this is the formula to find the middle index, lower plus upper, floor division with 2. I will get 2. So this index is my middle. This is the very first step. This is my middle. Now, once we have computed the middle, now I can decide whether to work on left part of the array, whether to work on this part of the array or whether to work on this part of the array, right part of the array. But how I will decide after finding the middle, how I will decide whether to work on left part or whether to work on right part. Okay. So for this, we will compare the middle index element with the item we are searching. With the item we are searching. Say suppose item we are searching is 10. Item we are searching is 10. Now tell me, 10 is less than your middle index element, or middle index element, whether I can say 10 is less than middle index element, that is, which is nothing but 30, or middle index element is greater than the element which you are searching, 30. Both are the same thing, right? So can I say after finding the middle, if array of middle index, which is 30, is greater than the item which you are searching, which is 10 in this case, here. So what I need to do, I will work on left part of the array. Why? Because I know I am searching 10, and if middle is 30, then no need to go beyond 30, right? No need to search on the right side, right? Because 10 is smaller, so it will always be the left side. Why? Because array is sorted. That's why for binary search this is important, that array has to be sorted, right? If my array is sorted and if 30 is in the middle, I can definitely say my element, that is 10, will always be in the left side. Say suppose if I am searching 60, then I know 60 is greater than 30, so it will be on the right side. Okay, so to work on the left part of the array, now I need to work on only this part of the array, only this part, left side. So how to work on the left side of the array, guys? I will simply write or change the value of upper. Upper is pointing here, right? What if upper starts pointing here? Then I will only work on this array and then we'll find middle again. Okay, so to change the value of upper, what I can do, I can simply write, if array of mid is greater than item, upper is equal to mid minus 1, middle index minus 1. That is, in this case it will be 2 minus 1 equal to 1. So your upper index will be 1 now, and your lower index is unchanged, it is 0, right? So now the array which you have is this. With you. It is not a new array, guys. Just for the explanation purpose, I am just writing it. Okay, it is the one array only, 10, 20, 30, 40, 50, 60, but for the explanation point of view. And its index is 0, its index is 1. This is now my lower, this is now my upper, right? What I will do again, I will again find the middle. Now middle is, this is the binary search, find middle and then keep finding the middle unless your middle is the item which you are searching. Lower is 0th index, 1 is upper index. So what I will do, I will again find middle. What is that? Lower, 0 plus 1, floor division with 2. What is that? 1 floor division with 2. What is that? 0. Why? Because 1 divided by 2 will be your 0.5 and I am taking 0 precision. So it is floor division. So it will be my 0. Now tell me, after again finding middle, this will be my middle now. Right? Middle is equal to item. Yes. 0th index has the value 10, which I am searching. So I will just return 0 in this case. Simple, done and dusted. This is my binary search, how it will work, right? Now, let's take a third step. Guys, here. Let me just clean it up. Now, what if this item, the third case, item which I am searching is 60, right? Then This was my case earlier. After finding the middle, this is if array of middle is greater than element. What if, else if, after finding the middle, array of mid, the very first middle, is less than the item. Suppose item I am searching is 60. After finding the middle, which was my second element, right? So I was having 10, 20, 30, 40, 50, 60. My middle is present at my second index, right? And the item which I am searching is this, which is my upper initially. This was my lower. This is my middle. This is my lower, right? Now, I know that the item which I am searching is greater than the middle. Then I need to search on the right part of the array, which is this. Now to search on the right part of the array, what I will do? I will change the value of lower, and my lower should point here. So I can simply write lower equal to mid plus 1, which is nothing but my 2 plus 1. Lower will be my third index, upper will be my fifth index. Then I will have this array. I will have this array like this: 40, 50, 60, third index, fourth index, fifth index. Item which I am searching is 60, right? Now lower is this one, upper is this one. Find the middle, which will be lower 3 plus 5. Lower index is third, upper index is fifth. Sum these two, do the floor division, and then 8 floor division with 2, which will be a 4, right? 4 is this. Now tell me the middle, array of middle, that is array of 4, is equal to 60. No. Then I will check this again. Now this is my middle. Fourth. Lower is third, upper is fifth. Now tell me, array of middle is greater than item, that is 50 is greater than 60. No, then this won't run. Now I will check again, else if 50 is less than 60. Yes, then I will shift to my lower. Lower will be my middle plus 1. Right? So currently lower is this. I will do middle plus 1, which will be my fifth index. So what I will have guys, I will have, say suppose I have this currently 40, 50, 60. Lower is here, upper is here, mid is here, and we know array of mid, which is 50, is less than 60. This means, so what I need to do, I need to append lower equal to mid plus 1, else if condition this. So what will happen? This is third index, fourth index, fifth index. So lower will be mid plus 1, which is 4 plus 1, which is fifth. So now lower and upper both are pointing here. Lower and upper both are pointing to the last index. Now again we will find middle. Lower 5 plus 5 floor division with 2. 10 floor division with 2. Then I have 5. Now tell me, array of mid is equal to item, that is 60, right? Yes. So return 5. That is the index at which is present, right? Now suppose I am searching 70. But 70 is not present in this array, right? So in this case, so what would have happened? Lower was less than equal to upper. Yes, it was. We have to run this while loop till this point. Lower is less than upper. So fifth index, right? So whether fifth index would have been equal to 70? No. So in this case, we would have returned -1. If lower and upper both are equal, still I am not able to find the middle, we will return -1. I hope it is clear. Lower and upper, they both were equal. 60 was present at the last index. I did the floor division, found the middle, and again 60 got returned. That is fifth index got returned. But if I would have searched 70, then at the last index only 60 is present. So I would have returned -1. So this is it. These three are the steps. Find the middle. If that middle index is equal to the item you are searching, return it. If not, then see, you have to work on left side of the array or right side of the array, and then do this till your lower is less than equal to upper. Till this point, you have to do all these three steps again and again till your middle element is equal to the item which you are searching. If it is not, just return -1. Now to implement these three steps, I can either use while loop, first way to implement binary search, or second way is to use recursion. We'll see both approaches, right? But I hope you have understood what is the concept of binary search, that it works on sorted array. Find the middle, decide whether to work on left part or right part. If the item you are searching is less than the middle, work on the left part. If the item you are searching is greater than the middle, work on right part. Just decide how to change the lower value and the upper value, right? And here there is one important thing. That when I'm finding the middle, most of the guys, they get confused here. I am putting this in parenthesis, lower plus upper, so that the sum happens first and then the floor division. If I will not write parenthesis, it will simply be lower plus upper floor division with 2. So this will be performed first and then the addition will happen, but we don't want it. So that's why the role of parenthesis is very, very, very important, right? Let me just quickly show you what I mean. Say suppose you are doing, you have lower value as like this, 11, upper as 13th index. Just for the example purposes, what is the formula to calculate the middle? Lower plus upper in braces, in bracket, divide by 2. What I will get? I am getting 12. Floor division, so that I get integer value. I will get 12. But what if I do not put this lower plus upper in braces? What will happen? First 13 divide floor division will 2 will happen. I will get 6. Then 11 will be added. I will get what? You yourself see. I am getting 17. The wrong value of the middle. So this is very, very important catch. You have to put this in braces. Okay. Lower plus upper floor division with 2. Okay. Now another important thing is this formula, lower plus upper floor division with 2, works well in Python, works super well in Python, because in Python there is no fixed size of the integer. But say suppose if you are working on the programming languages like C, C++, where the integer size is fixed, which is 32-bit, then this formula can lead to your overflow error. Not in Python, again I'm saying, because in Python there is no fixed size of integer. But in other programming languages where the size of integer is fixed, that is 32-bit, this formula can lead to your error. Say suppose your lower value is 2 to the power 31, the lower index, very, 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 very big value, and upper is also 2 to the power 31. Then when you will sum these two, lower plus upper, this will definitely exceed the value of 32-bit. In 32-bit, 1 bit is for sign, whether it is positive integer or negative integer, and 31-bit is for number. So definitely when you will sum these two, 2 to the power 31 plus 2 to the power 31, it will lead to your overflow error. Then how to handle this? In other programming languages, we just change the formula of middle. It is same, but just that lower. In lower, what we will add? We will add upper minus lower floor division with 2. This part will run first and then we will add the lower to it, right? Now say suppose I have 2 to the power 31 plus 2 to the power 31 minus 2 to the power 31 floor division with 2. This will return me 0. So 2 to the power 31 plus 0. I am still within the range of 32-bit. So this formula works for Python and other programming languages as well. And this will return the same result of the middle, same result, no change in the formula. Say suppose I have lower as 10, let's take lower as 10, upper as 15. Let's take the example. So lower plus upper divide by 2. If you will go with the previous formula, what you will get? Floor division with 2. What you will get? 10 plus 15, 25 floor division with 2, and it will give you 12 because it is floor division. Now if you will go with the new formula, 10 plus 15 minus 10 floor division with 2, 10 plus 5 floor division with 2, 10 plus 2, 12, still the same result. No change in the result. It's just that this is the way to handle the overflow. Okay, so very, very important thing. If you are going with this formula, keep the parenthesis intact. This formula can work only for Python and for the numbers which are less than 2 to the 31 in other programming languages. But this formula can work for any of the programming languages for any of the size of the numbers. Lower plus upper minus lower floor division with 2, right? Again, we are not summing these two first and then floor division. No, this part will run first. Upper minus lower floor division with 2. This will run first and then lower will be added. This is the formula to calculate the middle. So we going forward, we will use this only as this is more versatile, right? So I hope binary search is clear from the theory point of view. Okay, I guess the theory part is clear for the binary search, right? So what do? We have to do 3 steps, right? We have to do 3 steps. That is, find middle. What is the formula for middle? The correct formula: lower plus upper minus lower to handle the overflow error. Not in Python, but this is the general formula. This is more widely used, so I'm writing, right? So this will happen first, this, and then the lower will be added. Find the middle. Second is, if array of middle is the item which you are searching, right? Is the item which you are searching, then return this, return mid. Correct? This we have already seen. I'm just revising it. Else if, I can simply write else if array of mid is greater than the item which you are searching, guys. Is greater than the item. It means you have to search on the left part, right? Let me just draw it again. 10, 20, 30, 40, 50, 60, right? Middle is 30, say suppose, right? Item you are searching is 10. So you have to search on the left part. Then what you need to do? You need to change the value of lower to mid minus 1. Perfect. Now, if not, then in else, you can just simply write lower equal to mid plus 1. Correct? If this is not greater than, then I will have to search on the right part. Then I will have to make lower here. That is mid plus 1. Simple. And till what point I need to do? Till your lower is less than equal to upper. Because we have seen that if I need to search 60, my lower and upper both will become 5. Then 5 plus 5 floor division with 2 will give me 5, and my 60 is present at 5th index. I will return 5. But what if I am searching 70 and my lower and upper both are equal? It means 70 is not present at all. I will simply return minus 1. This can be solved using 2 ways. This can be solved using 2 ways: while loop and recursion. Let me just go to the PyCharm and implement this binary search using while loop. Okay, using while loop. Let me just clear it. Let me just define a function called as binary search, which will take my 2 arguments. Here array is array on which item needs to be searched. Item is item to be searched. Correct? These are the 2 arguments. What I will write now? What's the first step, guys? What's the first step? The first step is to nothing but define your lower. Lower will be initially your zeroth index. Say suppose on a, let's take this array in front of you, for example, in front of you, 10, 20, 30, 40, 50, 60. Array has to be sorted. This is sorted. If it is not sorted, there is no point of applying binary search. We cannot apply. So by default, lower will be the first index, that is zeroth index. Upper will be the last index. Can I write like this? Length of array minus 1. In this case, length of array is 6. Correct? Total number of elements 6. 6 minus 1, 5. So 0, 1, 2, 3, 4, 5. Fifth index is the last index. So I can write upper equal to length of array minus 1. Now I need to find middle. I can write lower plus upper minus lower, which is nothing but lower plus upper float division with 2. But to handle the overflow error, I am writing like this, float division with 2. So this will run first. What will happen? 0 plus 5 float division with 2 will give me 2. Then I will add a lower to it, which is 0. 2 plus 0, I will get 2. So middle will be here 2 for the very first time. Now, what I need to do? I need to run a loop till when lower is greater than upper. Lower is greater than equal to upper. But I need to find middle again and again. So I will write this line in the loop. I need to find middle again and again as per the value of lower and upper. So what I will do, if array of mid is equal to item, guys, return mid. Simple, no confusion, right? Else if array of mid is greater than item, it is greater than item, it means 30 is greater than 10, it means search on the left part. To search on the left part, I will make lower equal to mid minus 1. Sorry, upper equal to mid minus 1. Upper is currently pointing to last index. It should point to here so that I can work on the left part of the array. So upper will be mid minus 1. If these two are done, then I can simply write lower equal to mid plus 1. I hope it is clear. And I need to do till this point while lower is greater than equal to upper, right? Now, if all these things have happened and my lower is equal to upper and still I am not able to return that element in the mid, what I will do, guys, I will simply write return minus 1 or none. Return none. Simple. This is my binary search. This is my binary search. Let's take, we will debug it. This is using while loop. We will debug it step by step. We will do it. Let me just call it. Let me just define the array 10, 20, 30, 40, 50, 60. I am calling my binary search and the item to search here is, let's suppose 10. I am calling my binary search function. I am passing my array, I am passing my item, and I am printing whatever the result is returning. Simple. But before I run, let's debug on our own so that we can understand whether there is an issue or not. So this is an array 0 to 5, lower is 0, upper is 5 here, right? For the very first time, 0, upper will be 5 here, right? 0, right? Let's calculate this. 0 is less than equal to 5. Yes, it is correct. It is. So it will go into the loop because 0 is less than equal to 5. So middle will be 0 plus 5 minus 0 float division with 2. So it will be 0 plus 2. So middle will be currently your 2 at the very first step, which is correct. So it will say if array of middle, array of 2, which is 30, is equal to the item which you are searching, that is 10. No, right? So it will not run. So this piece will not run. Array of mid is greater than item. 30 is greater than 10. Yes. So upper will now changed from 5. From 5 it will be changed to 2 minus 1, mid minus 1. That is your 1. Upper will be now 1. Right? So it has run now. So what it will do? Now I will come again in the loop. Else won't run because else if has run. Right? So I will come here again. And now I will say 0. Upper is, lower is still 0. 0 is less than 1 because upper has been changed now. Upper has been changed, but this condition is still true because now my 0 is less than 1. It is true. So lower is still 0. 0 plus So what will be the formula? 0 plus upper is 1 now, 1 minus 0, floor division with 2, correct? So it will be 0 plus 1 floor division with 2. It will be 0 plus 0. It will be 0. 1 floor division with 2 will give me 0.5. I will take 0. So 0 plus 0, it will give me 0. Now array of mid. Mid is what? 0 is equal to item 10. Yes. So this will be returned. So 0 will be returned because 10 is present at my 0th index. I hope it is clear. Let me run this. I don't see any issue. We'll see if the issue will come. Let me just run. Yes, it is giving me 0 because 10 is present at 0th index. Let's just again change. Let's just do 60. Let's just do now 60. What will happen? Here it is again. When I will start here, it will be 0. It will be 5. 0 is less than equal to 5. Yes, it will come here. It will calculate the middle. Middle will be 2. Array of mid 30 is not equal to 60. Then it will not run. 30 is not greater than 60, right? So it will not run. It will come here. It will modify the value of lower. Lower will be now 3, right? Because this item is greater than array mid. So this will run. Now lower is 3. I will come here. So it will be like 3 is less than equal to 5. Yes, it is. So mid will be calculated again. 3 plus 5 minus 3 floor division with 2. 3 plus 2 floor division with 2. 3 plus 1, that will be 4. So mid is 4. 4 is nothing but your this 50. Array of mid, that is array of mid is 50, which is not equal to 60. So this will not run. Array of mid is greater than the item. No, this is also not true. Again, this will run because item which we are searching is greater than the middle. So lower will be now 4 in this case. Mid is 4th, right? Mid is 4. So lower will be now mid plus 1. So lower will be your 5, right? So I will come here. 5 is less than equal to 5. Last, because lower is less than equal to upper. Yes. So mid will be now my 5. Array of mid, which is this, equal to 60. Yes. So 60 will be returned. Let's see. Let me run this. I don't see any issue. 5 will be returned. Not 60. Sorry. 60 is the item index. 5 will be returned. Yes. 5 got returned. Now say I am searching 70. Let me just traverse it for the 70. Item to search is 70. Let me just traverse it for 70. Right? I am searching 70, which is not present in this array. Lower is 0. Upper is this. 0 is less than equal to 5. Yes. Mid will be 2. Which condition will run? This condition will run. Now, this condition will run. Why? Because 70 is greater than the middle element, which is 30. Right? So, your lower will become, for the very first time, it will become 3. Now, again check will come. 3 is less than equal to 5. Yes. So, middle will become 3 plus 5 minus 3 floor division with 2. Middle will become 4. Again, this is not true. This is not true. This will run. Your lower will become 5. 5 is less than equal to 5. Middle is your 5. Is array mid? Array 5 is 70? No. Array mid is greater than item, that is 60. 60 is greater than item? No. This will run. Lower will be now 6. 5 plus 1, 6. It will come here. It will check. 6 is less than equal to 5. No, this condition is false. This loop will not run. Else will run. None will be returned. Let me just run it. None is returned because 70 is not present. Simple. So we have seen all the cases, left half, right half, when the element is not present. So this is how binary search works with while loop. I hope it is clear. Just practice it. We'll see recursion now. So now it's time to see binary search with the recursion. We have already seen binary search with the while loop. The condition is kind of same. It's just that when we are updating upper and lower, instead of directly doing like this, we will call binary search again. Right? Let's see. So this is my one note. I am here and I will see my binary search through recursion. If you have not watched recursion, backtracking, recursion tree and all, I would highly suggest you to watch it in my course first, right? And then watch this video. So recursion, and we are doing binary search. So again, binary search, the very first step is array has to be sorted. So it will only work on sorted array. Second is to find the middle. Let's see, the array which I have is 10, 20, 30, 40, 50, right? So I have defined my binary search function, right? And this will take my array. And the item to search, and in this I will pass two arguments more, which is my lower, my upper, right? And what I will do, if the very first step, till what point I need to do, lower is less than equal to upper, right? If this is the case, calculate the middle. Middle would be what? The same formula, upper plus lower minus upper. This we have already seen, right? Floor division with 2. So say suppose I need to search 10 in this case. So lower is nothing but your 0. Upper is 1, 2, 3, 4, 5, 4, because 5 element, length of array minus 1, 4. So it will be, middle will be my 2 in this case. So I will write if array of mid is equal to item, array of 2 is 30, which is not equal to 10, right? But if it would have, we will simply return it. Else if, now this is main, array of mid is greater than item, 30 is greater than 10, item which I am searching, correct guys? So what I will do, instead of directly updating my upper equal to mid minus 1, I will again call my binary search with array, with item, with the same value of lower, because lower will be unchanged, but upper will be now mid minus 1. Very, very important. Or else, if this is not the case, else I will call my binary search with lower value as changed, add mid plus 1. We will backtrack it also. Just hold on and just try to grasp what I am doing. Else, if all these things are done and dusted, lower is greater than upper, what it means, I will simply write one more else in the indentation to this if, that return none or minus 1. So these two are the base cases. If item equal to the array of mid, return it, else do this, right? So let's traverse it. What will happen first? I am searching 10, mid is this. So what will happen? This will not run. Array of mid 30 is greater than 10. This will run. So what this will do? This will call binary search again. With the value of array, item, lower is 0, upper will be mid minus 1. That is this. So then binary search will be called again. Again it will be computed like 0 is less than equal to 1. Yes, this line. Then mid will be computed. Mid will be your upper. Upper is lower. Sorry, here not upper. Here I need to write lower. Lower plus upper minus 1. Lower 0 plus 1 minus 0. Floor division of 2. 0. Mid will be 0. Then if array of mid, that is array of 0 is equal to 10. Yes. So it will give me 10. So here 10 will come, and else if this binary search, this will return 10 and this will return 10, the main program. This is how recursion works, and we have seen the backtracking. Let me just go and implement this binary search using recursion. Array, item, lower, upper. Simple, correct? Now if lower is less than equal to upper, now I am not applying while loop, it is if condition, right? I will calculate middle equal to lower plus in braces upper minus lower, floor division of 2. Then I will write if array of mid equal to item. I hope it is pretty straightforward for you now, because we have already seen in that. This would be my base case. And what is another base case? if this lower is greater than equal to upper, I will return. Now I will write the else if and else inside this. Else if array of mid is greater than item, what I will do, I will simply return, binary search, same array, right? Same mid, I need to shift upper, and upper will be mid minus 1. And in this else part, I will return it. Now in this case, I need to search on the right part. So lower will be changed, mid plus 1, and upper will be unchanged. This is my binary search. Very simple, right? Let me just define one array, 10, 20, 30, 40, 50. Lower is my 0. Upper is your length of array minus 1, which will be 4. Then I am calling binary search. Item to search is 10, for example. Then I am calling binary search with array item lower upper. Let me just run it. What will happen? 0 should be returned, right? Let me just run it. It is returning me. Yeah. Here we have done return item. We need to do return mid. We need to not return item, guys. We need to return the index. Okay. So now 0 will be returned because 10 is present at the 0th index. Let me do it for 20. 1 will be returned because 20 is present at the 1 index. Let me just do it for 50. The last 4 will be returned. Yes. Let me just do it for 60. It is not present. None will be returned, or minus 1 will be returned. So I hope this is clear. This is binary search with recursion. We have seen both binary search with recursion, while loop. We have seen overflow issue. We have seen the correct formula of middle, right? We have seen it in theory. We have seen the backtracking. I hope it is clear. Practice it. Now let's talk about the time complexity of binary search, right? Time complexity. We all know what is the time complexity of your linear search, which is your ON. But what do you think would be the time complexity for binary search, right? In binary search, what do we do? This is one array, right? Say suppose this is one array. We find the middle, and then we decide whether to work on left half of the array or right half of the array, correct? Either we work on this half, left half, or we work on right half. We don't work, let me write, we don't work on entire array. We divide the array into half. This we have seen, right? We divide array into half, right? So if we are dividing it with the half, so its time complexity will nothing be logN, O of logN, worst case, big O of logN. And logN is a logarithmic representation where n is number of steps, which we have already seen, right? And logN means half of the steps, n by 2, right? So big O of logN is the worst case time complexity of binary search, because at any point of time we are dividing the array. And how we are dividing? We are finding the middle, right? And then we compare, right? Whether array of mid is greater than the item or array of mid is larger than the item, right? Then we adjust the lower and the upper. I hope it is clear. We'll meet in the sorting programs.